Hi, welcome to excelLab.org. We'll see how to calculate retirement corpus, and here we are going to use time value of money concept. So first let us see the problem. So here a person A and the age is 50 and he plans to retire after 10 years. His current expenses is $50,000 per annum, and as per his estimates the expenses will increase by 5% per annum till retirement. Also, he assumed that the inflation adjusted interest rate or real rate will be 5% per annum. So here we have to calculate retirement corpus, and the life expectancy is 75 years. That is, he will survive for 15 years post retirement. So here we are going to use two concepts. The first one is compounding and the second is discounting. So for compounding, what we'll do here, you can check here. So this is a timeline you can see here, and the expenses is $50,000 and it will grow at 5%. So this is pre-retirement period, and here we are going to use the compounding formula, and here I have written like FV equal to PV multiply with 1 plus rate of interest, and it is raised to number of year, n is number of years. So 50,000 is multiplied with 1 plus 5% raised to 10. Okay, so if we see on Excel, same thing. So here I have written the primary information. So the present age 50 and retirement 60. So the pre-retirement period is 10 years. These are the expenses, growth rate, and here we'll check what is the value after 10 years. So I'm going to use the inbuilt formula. It is called FV, future value, and I'll put FV, and we have the function here. Put the parenthesis, and first here we can see here the rate, and the rate is 5%. N per is number of periods, so in our case it is 10 years. PMT is annuity, so we will ignore it and we'll directly come to PV, and we'll put minus $50,000. So minus, since it is cash outflow, and I'll put the parenthesis again and we'll enter. So here's the amount, and we can see this is 81,444, and if we use the formula, let's say if I use the formula, so this is present value and it is multiplied with 1 plus r%, and it is raised to 10 years. So we got the same thing, right? So this is the formula I use. So we can do either using inbuilt function, or we can put the formula directly. So at the age of 60, so that 50,000 will grow to 81,444. Okay, next, now this is the amount he required during post retirement period. So now next task is to calculate the corpus. So for 15 years he will require 81,444. so what I'll do here again, so this is the real rate, which is 5%, life expectancy 75 years. So this is a post retirement period, that is he will alive for 15 years. Now next we'll see the present value of annuity, and first let me remind you the time value of money concept. So this is present value annuity, and this is how it works. Okay, so he will retire at 60, and this 61, 62, 63 until 75, this is his post retirement period. And when we'll put in the formula, so we'll get the value, like here is the formula, and this 81,444 he required each year, and uh, this is the discounting formula. Since we are dividing by 1 plus 5% raised to 1, this is for the 61st year, so we'll come backward. It's a discounting. And similarly, like for 62 also, we'll discount for 2 years. When he turns 63, we'll discount for 3 years. So similarly, like when he turns 75, so we'll discount for 15 years. So this is how it looks, and we'll check on Excel. So again, first I'll use the inbuilt function which is called PV, and similar to FA, I'll put PV. So rate is 5%, n per number of periods, so the expectancy is 75, so for 15 years. Then PMT, which is annuity, and here we required PMT, so I'll put minus, and each year he require 81,444, and I'll close the parenthesis and enter. So this is the amount. So here it is approximately $0.85 million he required as a retirement corpus. We can again put the formula here and check. So the formula is this, or this one. We can see this is A for annuity. It is multiply with 1 upon r% multiply with 1 minus 1 upon 1 plus r% raised to n. So I'll put the same formula here. So annuity, it is multiply with 1 upon r. So in our case it is 5%, and it is multiply with 1 minus 1 upon 1 plus r raised to 15 years, and we'll enter. Let me put this in parentheses. Sorry, I forgot to put the parenthesis. Now it's fine. Yeah, so we have the same answer, same solution if we write the formula also. So it is close to a $0.85 million